Let's move now to implicit threading. So implicit threading is something that is getting more and more popular. I mean, this has been happening since years now. It's not really something new. And it's basically about simplifying even further the life of programmers when it comes to multi-threaded processes. The idea is to let the compiler create code to handle threads so that the overhead, or let's say the extra work needed by the programmer in saying things like create a thread, destroy a thread, run this function with a thread, gets even lower than the one I presented with the code before. Okay, we're going to look at two ways or two mechanisms that exist. One is the concept of thread pool, and the other is OpenMP. So thread pools, it's something that is used quite a lot. The idea is that instead of creating a thread when you need it, you create a set of threads, a pool of threads at the beginning, so that first of all, you don't pay the price of creating a thread when you need it, because when you need a thread, you might want to do something rapidly, and creating the thread at that time would affect the, let's say, response time, latency, whatever you want as a metric, because you have to create a thread at that moment. So you can create the threads at the beginning of the execution and just keep them in a pool. And then whenever you have to run something in a thread, you pick one of the 3 threads in the pool and you make it run a certain function. Okay. Of course, you can play a bit with the pool size to decide what is the maximum parallel degree, and you can have mechanisms so that if all the threads in the pool are already taken, you can either decide to create more threads or just ask the one that wants the thread to do something to actually wait, because all the available ones are taken. And in practice, this might be also good, because you know that at the end of the day you have a fixed number of physical cores, and since each physical core can only run one thread at a time, having too many threads, depending of course on what kind of operations they're doing, especially if they are CPU bounded, we will see this next lecture, but simply put, if they do a lot of computation and they're not really requesting a lot of input output from the operating system and the hardware, then having too many threads doesn't really help. An alternative is OpenMP, not an alternative, an extra mechanism for implicit threading is OpenMP. So here the idea is that you actually use directives for the compiler, so that when you compile your code, the compiler automatically adds all the parts that are related to creating threads and assigning functions to them and so on. So basically, just look at this example. Here you see you put this directive for the compiler, and what you're telling the compiler is, look, everything that happens, or all the functions and lines of code you have in between these brackets, they should be run in parallel, and you should create one thread per core that is available in my computer. Okay. When you compile this, then the compiler will add all the extra lines needed to create the thread, destroy the thread, join the thread at the end to make sure the main thread doesn't proceed before this is done, and so on. So basically, if you try to do this, you will, and then you run the program, you will get n times this print, where n is the number of cores you have in your machine.